Good day everyone, and in the next activity is the whole supply chain one. In this activity, the problem statement states that a publisher is printing calendars for the upcoming year. Its demand for these calendars is normally distributed with a mean of 70,000 and has a standard deviation of 25,000. While the cost per calendar is fixed at $3 and they are sold for $10 each. While all the unsold calendars are gonna be recycled at the end of the January. Asking with this problem asks a two questions, which is how many calendars should the publisher have printed, and what is the expected profit for the letter A and letter B. And then the printer has offered to discount the printing cost to $2.75 per calendar if the publisher orders at least 100,000. So what should the publisher do? So moving on from that problem statement, there are two tables that displays without a discount for the printing of the calendars for the upcoming year, while for the second is having a discount. While for the without a discount, its expected demand will be 70,000 and has a standard deviation of 25,000. Um, while the given unit cost is or the regular price is set at $3 and denoted as letter C, while the sales price is set at $10 and then denoted as letter P, and then the salvage value is set at $0 and then denoted as letter C. So moving on from the understocking, which is denoted cost of understocking, which is denoted as letter CU, and then uh, this is $7 by achieve. This is achieved through um, taking the sales price and then subtracting it to the unit cost, which will arrive at $7. And then for the cost of overstocking, denoted as CEO, will arrive at $3, which will achieve by taking the unit cost and then subtracting it to the salvage value. So moving on to the output section in this table, it displays four parts, which is the optimal cycle service level, the optimal order quantity, and then the expected profits and the expected overstock. So for the optimal cycle service level, and this can be achieved by getting the cost of understocking divided by cost of understocking as well as adding the cost of overstocking to get this 0.7. For the optimal order quantity, this is the formula, which gets by getting the probability or the mean of the expected demand, the standard deviation of demand, and then the optimal cycle service level. 83,000 and then 110. Um, then next is the expected profits, which is $403 and then 0.77. And this is the formula. By This is achieved by taking the sales price minus the salvage value and then the normal distribution of optimal order quantity minus the expected demand over the standard deviation of demand minus the sales price and then the salvage value while multiplying it to the standard deviation of demand and then so on. And lastly is the expected overstock, which is 17,869. And this is the formula. So, to answer the question from letter A, the publisher can print over 83,110 calendars from the optimal order quantity, while for the expected profits of the same question is the will result of 403,077 dollars. And then the lastly is the 70,869 for the expected overstock. Moving on to the dis discounted with the discount, the inputs stay the same for the expected demand and then the standard deviation of demand. While changing the unit cost of for 2.75, and then the sales price is $10 as the same, and then salvage value is same as without a discount. For the cost of overstocking, the formula stays the same, resulting in 7.25, and then the cost of overstocking is 2.75. Taking the sales price minus the unit cost will arrive at 7.25. And then for the cost of overstocking is achieved by subtracting the unit cost to salvage value, which will arrive at 2.75. For the outputs of the with discounts, as stated in question B, is 100,000, and then the expected profits is achieved by the same formula uh, as the without a discount, and which will arrive at resulting in 410,000 and $974. While the expected overstock for this section of with discount is resulting in 31,400, and this is the form. So in this scenario, the publisher can increase their expected profit by ordering the 100,000 calendars at a reduced cost of $2.75, and then resulting in a profit of $410,974 with despite an increase of expected overstock of 31,403 calendars. And then that's all for my presentation in whole supply chain.